Okay, so still looking at 281 number 9b. So finding the magnitudes of vector BD. So from point B to point D, you're just going to use the Pythagorean theorem, square based. So that means that's a 90-degree angle in there. Okay, so you're going to use Pythagorean theorem here with BC and CD, which is right here. So magnitude of BD squared is equal to the magnitude of BC squared plus the magnitude of CD squared. Okay, so when you're working with vectors, you need to use vector notation. So you can't just sub in here Pythagorean theorem and just be sloppy with it. You have to write it out with the vector language. Okay, so you have to write the vector sign over the point-to-point vector BD and the magnitudes, magnitude bars, and squaring that. Okay, and then you can sub in the numbers. And when you get to the point where you can calculate the magnitude, you either leave it as an exact value, depending on the context of the question, or you put an approximately equal sign here, if you can only approximate it to whatever decimal places seem reasonable at the time if it's not asked for. So that's for the magnitude of vector BD, and then BE is along this side face here. It's a diagonal, so you're going to use AB and AE. There's a 90-degree angle in there as well. Okay, so that's a right triangle. Same thing, Pythagorean theorem for that. And you should get 13.19 units. Okay, that good so far? And then the last one, which is a little bit more complicated, they want you to find BH. So it's the diagonal of the whole prism. So from one corner to the opposite corner, right through the middle of the prism. In this case, you can make a right triangle in a couple of ways. You either have this vector BD on the bottom and the vector DH, which goes up the back side, and you can make a right triangle there. So you've just calculated out BD, and then you can use DH. Or you can use BE and EH, because there should be a right angle in between at this point here. Okay? So I'm going to choose BD and DH. So for this one, all right, BH magnitude squared equals BD squared plus DH squared. Okay? And we know these numbers. BD squared is what? Yeah? 18. So we can go right back up here to the exact value. If you square root 18, you're going to get 18. Okay? And DH squared is going to be plus 8 squared, which is 64, right? And 64 plus 18 is? Pardon? 82. Okay. So then magnitude of BH is square root of 82, which is approximately, pardon? 9.06. Anybody else confirm that? Yeah. Okay, good. Okay. So that's a little bit of a 3D problem. Yep.
For questions like this, do you want to sort out like the exact number, or can we read it as like the square root of 82?
Good question. It will probably be embedded in the question. If I ask you on a test or a quiz, it'll probably say round your answer to 2 decimal places. Or if I say nothing, show them both. Okay? Or ask. Ask during the test. Any other questions? Yep.
For example, like when we're calculating BD, you used BC and CD. Could we possibly use the other one since it's a square?
Yes. Yeah, you could use the other ones. Okay. Now I'm going to show you something else that will work for this. So imagine for this one you didn't calculate BD or BE and you still have to find BH. Okay. Well, I'm going to sub in a bit of a formula here. Might complicate it a little bit, but it's going to be useful in the end. Okay, so BH squared, we already have up here, equals BD squared plus DH squared. Right? So this isn't new, this is what we already knew. If we go back up and we look at what we have for BD, well, we had BD squared equals BC squared plus CD squared. Okay, so I'm going to input that for BD squared in this formula at the bottom here. Okay, so BD squared equals BC squared plus CD squared. Just using Pythagorean theorem. And then we write on the end plus DH squared. Okay. So this is kind of neat. If we go look at this in the diagram. Okay. So BH squared equals BC squared plus CD squared plus DH squared. Go up here. BH squared equals BC squared plus CD squared plus DH squared. It's kind of a three-dimensional Pythagorean theorem, isn't it? Okay, so I'm going in one direction, the other perpendicular direction, and then the other perpendicular direction. So it's kind of like the X, Y, and Z. Okay? So if you didn't have the other ones, you could use this formula here. So it's basically the three vectors that make the path all the way up there, and they have to be perpendicular. Okay? So that's basically Pythagorean theorem in 3 dimensions. You can calculate that out and see that it actually gets you the same value that you got in the other method. Okay, and it should.